Welcome, I'm Bill Greenway, and this is a kind of a quick snapshot, state of the question or state of the art presentation on just a variety of environmental challenges that face us, or challenges to what I'd like to think of in terms of creation care and love for all creatures. It's just a snippet of an extraordinarily complex set of issues to be addressed, but hopefully it's a beginning look at some of the challenges we face, and mainly it'll be pieces where I'm just gesturing at different issues and places to go look at them. You'll be able to see the article titles. Of course, you can pause your video, write down the title, Google search, and I'm taking that as being the footnotes to the different screens that I'm going to show you, so you can go and find the articles yourselves, read them, read the articles that many of the newspaper articles, and many of them are based upon other publications and scholarly researches, so you can follow those trails now very conveniently through hot links, follow topics in time. I'll be assuming you're going to do that, and so we'll otherwise not be mentioning the sources for the most part, just counting on you to be able to see them on your screen and find them easily with Google if you need to. It can be a little daunting to confront all of the loss and all of the challenges that are facing us in this age. I mean, we are bigger than Earth for the first time. Humanity is. The future of what species, what mountains, the health of the oceans. I mean, for the foreseeable human future, for this iteration of life on Earth, if we mess it up, Earth's got a long time left. There could be other iterations of life that come about, but for all intents and purposes, for our iteration of life on Earth, the species that survive our day, the mountains, the rivers that survive our day, are the ones that will be there for our kids, our grandkids, for humans in the foreseeable future, and eons into that future. And those that are lost for that future. So we are kind of a critical couple of generations here at a bottleneck where we are bigger than the planet, and for the first time, in a way the ancients could never have imagined. We literally are gods on Earth, in terms of it's going to be us who determines what Earth looks like in the future. Exactly how many rivers, how many mountains, how many species, with what flourishing, what is there going to be? And so this is a vital time. Take a look. It can be discouraging, but don't forget to take joy in what we do have right now, and to work to make things better than they would be otherwise, even if we're not going to be able to make things perfect, and simply to be honest about what we're facing, and being called to the struggle out of love, and being inspired by that love. That's a love that can energize us, give us joy and resilience and strength in that which we're striving to save, even as we face challenges and obstacles, and even defeats. It's to keep that in mind, especially as we look at this, which can be a little bit overwhelming, I think. So just a heads up there to keep track of the way in which, with creation, I mean, it's a source of spiritual power for us as well, and one that we can still glory in and be thankful in, even as we may mourn what's being lost, and even then as we struggle to save what can be saved. All right, I'm going to start, as you can see on the screen now here, with climate change. This is the Bulletin of the Atomic Scientists webpage. It's a good place to go for good scientific information. This website, you can see these things are dealing with multiple issues related to climate change. It supports, of course, other things as well that are important, but this is a good go-to source. Let me just start out with some basics. I think we've all heard of climate change. But this is CO2 we hear a lot. There's other, methane, for instance, is another very significant greenhouse gas. It's much more powerful and longer. I'm not sure if it's longer lasting. It's much more powerful than carbon dioxide. But carbon dioxide is maybe the single biggest driver, or at least a significant driver. And just to see here, this is an 800,000 year. So these 800,000-year-old graphs are based on ice core samples that are taken up out of the Arctic ice, I believe it is, or maybe in Greenland. But anyway, so it's an actual measure of atmosphere caught in bubbles in ice from that period. So it's a very accurate sample. And this is the range of CO2 in that time period. Of course, human history and evolution is just in this recent period, but you can see that we are in absolutely unprecedented territory, and this line is continuing to go up. That's why it's been such a significant thing, and you can see that what's gone, really the level that it's risen from 1950 to the present is just in geological time. That's the equivalent of what's happened over hundreds of thousands of years in these other periods. So that's the rapidity of the change of pace. What exactly that means, it has lots of different implications, as we'll see, but just to be aware of, that's why it's focused on. This also then relates to temperature changes, and I want you to see this is also the 800,000 year chart, also from the ice cores. This chart correlates roughly with the CO2 chart, although the temperature shifts evidently predate the CO2 shifts slightly. There's still thought to be a causal relationship there, but it's not absolutely straightforward. But most scientists agree that there is some sort of causal relationship such that the increased CO2 will certainly lead to increased warming, and that certainly seems to be the case. But what I want you to note mainly here is that this is this is the last 800,000 years. This is the average temperature in the last 1,000 years, so that becomes 0 centigrade, and you can see we're above that right now a bit, just in this recent time period, but we're right here at 0. But what I want you to note especially is when you get here, this is an ice age, right, where it's down. These dips low are the ice ages. And so this is the last ice age. You can see it's the coldest of the ice ages compared to the average of the last 1,000 years. But what I want you to note is the temperature difference there. So this is, just speaking roughly, the difference between, Manhattan, New York as we know it today, and a mile of ice over New York, something like that, is a 10-degree centigrade difference. And so when people hear about these global averages changing, sometimes it can sound like, 2 degrees, 3 degrees, even maybe 8 degrees in the worst case scenarios. 8 degrees doesn't sound that bad. I don't mind it being 78 instead of 70 or something like that. But that's different. We're talking about average temperature, where 10 degrees is the difference between a mile of ice over New York and the atmosphere we have today. Now, of course, we're going in the other direction, but that's where you need to keep track of this 2-degree goal, which is this ideal that all of you keep hearing about in all the international accords, but which actually looks to be unmeetable given what nations are ready to do. That's 2 degrees out of a 10 towards that sort of ice age. And if we don't take these sorts of actions, then worst case scenarios, it gets very severe. But even this, you can see the magnitude of change and the shift in rapid time scale as well. I mean, unprecedented almost in its speed. Now, we've had these radical changes before, right? In history, you can see them here, some of these radical things. But this is not a good thing. These have been associated with mass die-offs, mass extinctive events, ends of ages. So to the degree we can avoid having that happen, and the degree we're threatening with this sort of rapidity of change in temperature and what that means for all different species and all interactions, this is where this becomes a very serious issue. Here's the last 2,000 years. You can see it's going up. I think I want to go to the next chart to talk about something else. The main thing I wanted you to see here was, however, how to think about 2 degrees or 10 degrees in terms of centigrade changes in climate, average global climate. And when you think of centigrade changes, of course, we used to call it global warming, but for scientists, when they phrase this, they weren't thinking of, newspapers and stuff. For them, warming means energy. So it's more energy in the system. So the other thing to expect from climate change, just like any chaotic system, if you add energy to it, it gets more chaotic. So when you get extreme colds that are unexplained, right? Like a few, almost 10 years ago now with the Olympics, where we had snow in Alabama, but it was warm up in Canada where the Winter Olympics were. These sorts of things. Now that can be just local variations, but what's not unexpected and what we've had is an increase in severe weather events that would be expected, both colder and hotter. That when you put energy into a system, then the system becomes more chaotic. You get more extremes, even as on a whole it's going to warm globally, warm in that sense. But that's why they can say climate change now, because climate change in some places, in some seasons for some events, might be more extreme. Cold. Okay. The other thing, let me just say about predicting the climate. I think we're past this now, but people say, well, how do you know what's going on in 100 years? I don't even know what's happening, next week or tomorrow for sure. We're trying to plan a picnic for tomorrow. What exactly is, we don't know. Well, it's like if I, took a piece of paper and folded it up and dropped it, down to the floor. Well, given all the variations in the, how the paper is folded, wind currents, how it reacts to the wind, I don't think the greatest supercomputer in the world could say exactly where that piece of paper is going to land on the floor just a few feet away. But we all know it's going to land within a 2-foot circumference of when I drop it, right? So that's what it's like with the weather. It's very hard to predict precisely what the weather is going to be in 2 weeks. But when it comes to making large-scale predictions over large periods of time, there you have a much higher degree of certainty. Just like I may not know the weather tomorrow for certain, but I know in 5 weeks it's going to be a lot hotter here in Austin than it is today. I'm talking in late April. Okay, so just some things to think about there. This is the temperature record of recent temperature. This is the disagreement. That's what this chart is about, is here are these things disagreeing. But you can see, despite the disagreement, they're all predicting very similar things. And this is a sort of robustness of a lot of this theory. You have various ways of doing the calculations, stressing different factors where there's uncertainty, but still there's an incredible overlap. On the other hand, what I want you to see, especially here, and this is something too, I don't see it as much anymore, but you could say, let's say, I think this is around 1998, and you go from 1998 to here, and let's say that's around 2008 or so. And so you look at this, let's just go with the NASA one, the red one here, and you'd see headlines saying, global warming is a myth because the average temperature has actually decreased for the last decade. And that's actually true. If you go from this point, you can see my cursor there, down to this point, you could say, oh, gee, goodness, the global that 10-year period. But and this was in mainstream newspapers. It was stunning. Once you see the whole chart, you can see that to say the temperature is decreasing because of this is somewhat misleading. Even on this date, it was somewhat misleading, when there was maybe some hope that we were wrong and there could be optimism, maybe this would head back down. But clearly, when you look at the record over a long period of time, and this is now an actual recorded record, we have a steady increase, and that's just continued to increase since this chart. So, and again, this is average, so this is degrees centigrade. This is a shift from, this is the average, usually this is the 1950s, 1980 average, something like that. I'm not sure what it is on this. But you can see, again, centigrade. This is a significant increase when you remember it in terms of the distance between an ice age and the weather we have today. Okay. This is a great place to go. A fact sheet, global climate change, put out by NASA. You can see all of the various things. I'm just giving this to you as a reference you can look at. This one is specifically about ice sheets. What's been a very significant decrease in the mass of ice. This is significant for several reasons. One, ice reflects the sun rays, so it's a really good way to combat global warming. So is the Arctic polar ice cap in particular decreases, and that's all over water. It becomes dark water, so now the water absorbs more. So you get a feedback loop, which is not helpful, because the loss of ice actually leads to more dark water, which instead of ice reflecting away is water absorbing sunlight. So it becomes a feedback loop in which the warming leads to more warming because now the water is absorbing instead of ice reflecting. That sort of loss of ice is not significant in terms of sea level rise for the most part. It's because it's ice on water, so it's already accounted for in the sea level. That's where the Antarctic ice. Some of it's on water, but a lot of it on water is holding in ice on land, massive amounts of ice on land, or the ice on Greenland, which is also on land. When that ice flows into the ocean, that's where you get the temperature rise, and that's where you'll see a watching of ice sheets. Also, in terms of ice, there's a threat, and I'm just not remembering off the top of my head. I think I have it later here, but let me go ahead and say it now, to the world's glaciers. And the thing about glaciers is, which are feeding back, is a lot of them, glaciers are natural dams. They build up and collect snow slowly in the winter, and they release it slowly over time in the summer. So there's lots of cities and whole regions of countries which are downstream from glaciers and depend on that slow accumulation in the winter when there's plenty of water and it's cooler, and then the melt in the summer, which doesn't decrease the size, but is a slow release of that water into the rivers. As those glaciers disappear, all that water that does come hits and flows out. And so now all that water is lost. And so in place of these natural dams, which many communities are, and even major cities are dependent upon for a steady water supply, the loss of glaciers could lead to more flooding in the winter and drought in the summer. That's where, and of course this all varies for location, but just to give you a sense, this is how these complexities can work out at regional levels in very different ways that are significant. This is a famous essay by Bill McKibben in Rolling Stone from several years ago. Here are the numbers. He said the three numbers, of course, 2 degrees Celsius. So that's what scientists think we can do that. We can have that much. And again, now you understand that's a significant average temperature rise. It will have significant impacts. It's going to make a difference. Be something to deal with, but it looks like it's manageable. That if we can keep the rise to 2 degrees, then we go forward. And of course, that's 2 degrees by 2100. It's not like time stops then. So the things that we put into place to slow or not at 2100, 2150, things will keep getting worse or better accordingly. That's why we are such a pivotal generation, knowing now what's going on and be able to make a difference that's going to make a huge difference down the road for our next generations. 565 gigatons, that's the second number he names, and the reason he names that is because that's how much more CO2 can go into the atmosphere by 2050, and it still looks to be realistic that we can keep that 2 degree number. And then the third number, which he says is the problem, is the 2,795 gigatons, and this represents the number of proven carbon reserves, coal, oil, natural gas, that countries which are petrostates, so they're nationalized companies, petroleum companies essentially, or private coal or oil companies, this is the amount that they have as proven, which means it's on their books financially in terms of the worth and the future profitability of the company. So that's this financially, the difference between this number, 565, which is how much we can put out there, and this number, which is how much is already proven, let alone looking for new sources. This is what's already proven and claimed and figured into financial calculations. This is, in some ways, the bottom line that has to be addressed and figure out how to be addressed. So it's interesting here. I wrote my first essays or opinion pieces on climate change and the threat of climate change and the prophetic need to address it, because it looks like it's going to have a disproportionate harmful impact on people who are already relatively poor, especially in equatorial coastal regions where there's a huge preponderance of folks who are poor and impoverished, but also where it looks like we might have some of the most crushing sort of consequences of climate change. And so I wrote these editorials, and of course I was hardly alone, but it was a much more marginal topic back then, back when George Bush was still governor of Texas. And I remember then the worst case scenarios that we were projecting then, right, based on what the scientists were saying, are now the best case scenarios if we can keep climate at 2 degrees Celsius, roughly. The worst case scenarios today are simply unthinkably. It truly is an existential crisis. So people don't even tend to put those out there anymore because they can be stultifying because they're so terrifying. But that's what this is about, how scientists got climate change so wrong, about how the predictions that we were working with 20 years ago, it turns out were all wrong because they were all too conservative. They were all too optimistic. Climate change has been happening far faster. The feedback loops have been far more negative than we had understood. And let's be clear. Let's hope that we're wrong still, and there's, that we're going to get more cloud cover, that something else is going to happen that's naturally going to reverse these dynamics, so that we'll have some wonderful discovery that allow us to figure this out. But that's not in fact what's happened so far. All right. And this goes with that. Of course, the production is on track for double the safe climate limit, which would be that 2 degree limit. And it also turns out this was a groundbreaking, Pulitzer Prize winning essay, Insight Climate News. Again, a marginal newspaper that did this reporting that then got picked up by the New York Times, Washington Post, and others. And it turns out that it according to these essays, it looks like Exxon and other big industries, but here Exxon knew about the climate risks and long ago. And could have taken action to try to mitigate the risks, to adapt there, but did not. So to check this story to get the thing. Once this came out, here's another one from The Guardian. This is just from this March about again the role of those who had money to make by through petrochemicals, the role they had. Again, I can't get into this here. You need to take a look at it. This has led to such a degree that you had New York attempted to sue these companies. Their suit was tossed out. I forget exactly why. Massachusetts suit, I believe, this is now 2 years ago. I'm not sure what's happened to this suit, but there's various states now looking to actually see if what went on in terms of the covering up of information and influence actually rose to the level of breaking the law. The J.P. Morgan economists warned climate crisis is a threat to human race. This is an internal report. J.P. Morgan, I think we have another, maybe not, but they were a major financer of the oil industry, and so and this is if you work for these companies, if you run these companies, your fiduciary responsibility, and really in many ways your legal responsibility, is to act to maximize profit. So we need to not simply vilify the people who work in these companies or even the companies per se. They're set up in the whole system to operate in certain ways. And so we do want to make clear, especially in terms of these being corporate citizens, insofar as their behavior is harmful to everyone, but it's also important to establish ground rules and make other sorts of sophisticated, carefully thought out adjustments, which help incentivize these companies differently, give them a chance to do things differently. Although I don't want to be naive about the fact that there's other people who are simply greedy and selfish, and they're going to do what they can no matter who they're going to hurt. But even as we're concerned about what various companies are doing, it's important to have a complex idea of the position various players individual people find themselves in, and what their possibilities are, and how to move so that we can, because there's many really good people in these companies as well, but they're caught. They're caught by different financial obligations, by fiduciary obligations, as we'll see in a couple of minutes. Even the way the law is written in the states where they are legally headquartered, in terms of companies based here in the U.S. Anyway, in the last few years, the Juliana versus United States, there's a lawsuit brought by a group of young people claiming that they had a constitutional right to a livable climate in the future. And so the U.S. government, insofar as it was knowingly pursuing policies that either allowed or actually facilitated the creation of an unlivable climate, that the U.S. government was liable to change those things. It was a violation of their constitutional rights for the U.S. government not to pass laws, not to keep legislation in such a way, and not to withhold subsidizing of practices that would do that. And the United States, so is it our constitutional right to live in a world safe from climate change? I mean, really, is it our constitutional right to have a livable climate? Is the question. And what the United States has argued in reaction to these young people, interestingly enough, is not that they're wrong, that currently it looks like that they may not have a livable climate in their lifetimes, but they don't have a right to it. That's what the U.S. government has been arguing, that they don't have a right, that we don't have a right, our children don't have a right to a livable climate. That's the official, has been in this, according to this reporting, the stance of the U.S. government. And this is the U.S. government and policies under multiple administrations. So we'll see what happens. This was the argument. It was appealed up, and they lost this. And what's stunning as I read it, and if you're a lawyer, then it might be good for you to read this and figure out exactly what it does. But it looks like the court, as this says, confirms government's contribution to the issue, but find they lack power to enforce climate policy decisions. So I'm not enough of a lawyer to understand this precisely, but it's rather stunning to me that what the court, it looks like, decided was not that they were wrong in their contention or even in their right to have a livable climate. So and again, go look at the table, but I believe what the decision says, and I think this can be appealed. I'm not sure what's happening to it, is that they were right, that the climate was threatened, and that they had the right, but that changes would be required to realize that right. The court just didn't think it could oversee sufficiently. And so it threatened, I think, technically a separation of powers, because suddenly the court is having to oversee this. And that was the basis for the case to be dismissed. It's interesting to me that this was a huge issue that's been going up. This essay here is from January 2020. And this was in the year prior to this. What I saw in the newspapers was all about Extinction Rebellion. I don't know what happened to them. They just have disappeared. And Greta Thunberg, who I'm glad she's speaking out. But neither what she's saying, Greta Thunberg saying, or anything Extinction Rebellion actually ever did, had real regulative teeth. The Juliana decision, if this case had gone through, I mean, as the court itself acknowledged, the reason they didn't find for what the technical term is, the kids, the reason they didn't find for Juliana, the kids on the Juliana side, was precisely because it would have had such teeth that suddenly the U.S. government would have to make sure that it was acting in such a way so as to ensure a livable climate for these children as they grew into adulthood. So just to keep track of these various differences and where these things might make a difference. More of the same here. I'll let you. So this is just actually from March of this year, 2021. So in the wake of everything that's been known, in the wake of even the Morgan Stanley analysts warning before, this continues to be the case. And again, it's it's not just, okay, big banks are evil. It's big panks, none of the players are all doing their fiduciary responsibility. In many ways, their legal responsibility. And the only thing that in terms of major players, won't get them fired and just replaced by someone else who will do that, right? It's got to be a bigger picture. That's where actually the decision against Juliana is a shame, because that's the level of structural change that we need so that everyone's allowed to move in ways that will produce a safe climate for all of us. Big business, again, this is something to take a look at. The reaction, of course, and again, consistent with each player's goals. As you see what climate is doing, your incentive is to figure out how to make the most, how to secure the financial future of your firm and its shareholders, right? Not to be part of the big picture. What I'm keep gesturing towards here is the need for governance, which is not controlled by the logic that's intrinsic to each of the major corporate players, where the goal of the corporate player is to maximize profit, and where that can't be made secondary to other goals like having a survivable climate. So all right. And this is something to keep track of as well. And this does get, again, let me just take a look at that and how it's done. But I want you to see this is the sort of thing, this, and you can go read this essay and also do the other detail work. But in Delaware, where many corporations find their home, it's actually not legal, for companies to put anything above shareholder value. As the article says here, the Chief Justice of Delaware's highest court recently just said just that, warning that executives who take care of an interest other than stockholder wealth breach their fiduciary duties. That's what I mean about the executives being controlled, right? So ironically enough, part of the answer to this might be dealing with corporate governance laws and corporate law in Delaware and elsewhere too, right? So you don't get what happens is it's not just Delaware, it's bigger than that. Anyway, I read these things. I'm trying to open up these areas and these logics. When you read a lot of, even in environmental ethics books, if you read economists talking about it, they'll talk about rent-seeking behavior, which is always, it seems like, written with a tone of contempt, right? This is terrible behavior. What rent-seeking behavior is behavior that looks to get something for nothing, right? In other words, anything that you want, that it's not going to provide a profit to the other party, and as you can see in much of this, that means a monetary profit, is rent-seeking behavior, which means basically a lot of what we call for in the church, right, which is to do something because it's good, because it's loving, because it's just, even to be willing to sacrifice yourself, right? That's where the cross, for Christianity, is the ultimate symbol of this. You go even to the cross out of love, out of fidelity to what's good for your neighbor, what's just for your neighbor. This is in many of the operative logics which control global discourse about economic realities, which is about industrial realities, which is about everything we're talking about, the environment. All that we're looking for in terms of appeal to what's good and what's loving, even if it means sacrifice, would get categorized as rent-seeking behavior. So this is where these logics need to be somehow this is where the religious logics, not just Christianity, of course, need to be given traction along with the economic logics, right? So you can't be unrealistic. You've got to attend to the economics. It's a matter of putting things in balance so that other goods are also given real traction in the discussions and the negotiations. This is where Pope Francis's Laudato Si is such a marvelous document, because it goes through all these different sorts of transnational regimes, which are largely going to be determining how things will play out, in fact, into the future, and talks about how to get other voices representing other values into the negotiating rooms. So that the transnational agreements and the other sorts of regulatory and agreements, the regulators who are set up, all of these things are not only informed by kind of realpolitik and the need to attend to the bottom line, but also informed by ideals and what is good, what is loving, and what is just. And that I think is a constructive and fair way forward. So let me recommend that document. The global heating, it's unfortunately the impacts, as I said before, tend to be disproportionate in ways that look like they're going to fall the hardest on those who are most impoverished in the world. There's also a way, and this is what I was trying to mitigate against at the beginning of this presentation, although I confess to often feeling this myself, and anxiety that now is arising, and I think that this compounds the problem, right? So we need in a way to take joy in the creation we have, the beauty we have, get energy from that, do what we can for the future, but also do what we can to keep from this sort of depression. This was just coming out a week ago, a pastor doing this, but also about trying to give a congregation a sense of purpose and hope through action. National Academy of Sciences is another great place to go to get news. This is climate resources. The one maybe disturbing or potentially disturbing, it's hard to know, thing that's happened recently is they've endorsed geoengineering projects on an experimental basis. This is an article that came out just April 19th, a week and a half ago. So if you want a nice, up-to-date summary of climate change issues, this would be a good place to go. I'm going to get back to the climate engineering. This is a sense of also unexpected ways in which climate change seems to be making an impact. And there's some hopeful things happening recently with what's going on with the current administration and also with the Senate and other moves. But we've had these sorts of things before and they haven't been sufficient, or they haven't been given regulatory teeth. They've been made voluntary, which again, this is where you have to be, when you make something voluntary, doing it puts firms at a competitive disadvantage over other firms who are bad actors. That's often what voluntary turns into, is those who are doing the right thing, insofar as they can even afford to do it, will do it at the cost of a competitive disadvantage. And so you actually end up in the long run helping out the bad actors. That's where regulations, international regulations with teeth, is the fair way to go forward. And as long as things remain voluntary on all of these things, then just the logic of how these corporations work, how these corporate logics work, and even if you have really good people, if insofar as it's wholly voluntary, you set up something which is not going to be successful, especially in the long term, because it actually ends up giving advantage to those who are the bad actors. So this is a reference back to what I was saying a second ago about the National Academy of Sciences. So the sense of some people, and this is maybe a realistic sense, is in fact we're not going to do enough. The way the profits are lined up, the lack of a global kind of regulatory structure, the amount of money. I mean, remember that huge number of proven reserves in contrast to the number of gigatons of CO2 that we can put into the atmosphere. There's a lot of people that have concluded we're not going to hit 2. We're not even going to come close to 2. We're going to be looking by 2100 and then later, because things are going to keep building. It's not like it stops then. We're looking at essentially an existential crisis. And so extreme measures are going to be necessary. And that's where we get to geoengineering. So there's several different varieties of this, but one of the most one of the legs right now is to do something that would roughly imitate a volcanic eruption, which we know will decrease the greenhouse effect, will cool the planet, but we'll do this artificially with particulates or gas we'll put in the upper atmosphere. And so some people think that this is going to have to be a part of our climate future if you're going to have to geoengineer at a planetary scale. Now, when we've done this at lower scales, the problem is the unforeseen complications, which in the past have tended to come up and be very problematic. The other concern is once you do this, now you're dependent upon this to keep things cool. You've got to keep doing it. The other thing is when you do this, the way it will play out in different regions will be different. And so how do you do it? Who decides where we're going to put the particles? Who's going to be impacted? How is that done in a just way? And how are we even sure of what the long-term consequences will be? These are all really large questions, especially the unintended consequences, which at this point are at a global scale with something which, if we live into it, it would be hard to stop doing. We're kind of wholesale committed to it. It also means that now that future is in the hands of whoever it is, whatever agencies, whatever entities are actually tasked with doing that. Is that a for-profit? Is that the other thing about that is it doesn't change the rising CO2, which has other impacts on the atmosphere. For instance, ocean acidification, which we'll talk about. As you increase the CO2, it changes the acidification. This has consequences for all sorts of sea creatures. Anyway, but so the dangers and the complications of geoengineering are really frightening, really daunting. So much so that until recently, scientists were like, this shouldn't even be researched. It's open now because it really is an existential threat, and people really are skeptical that we're going to be able to take the governmental action to be necessary to keep the climate under control. Given that extreme, then really risky measures look reasonable. That's where this becomes an actual argument, and with legs, where there's disagreement among good and informed folk. But the reason it has such legs is precisely because the problem is so significant. And the chances of us actually moving beyond lip service and making the changes needed to meet the challenge seem so remote. So the same goes with nuclear power. I think Bill Gates, he has a book that's come out recently, I understand anyway, that he's advocating nuclear power in that book, trying to come up with, working I think in other ways to come up with safer nuclear power plant technology. After Fukushima, when we saw in one of the most technologically sophisticated nations on Earth how just a single earthquake and tsunami in 4 days could take a nuclear power plant to an absolute crisis point, which endures to this day, to the point where, as we'll see later, they're going to be releasing radioactive water into the ocean. But nuclear power, after that and even before that, many swore off because the consequences of an uncontained failure of some scale, which is real potential for, are so great that the idea that we would expand nuclear power plants has been unthinkable. But it's kind of the same thing as with thinking about geoengineering. If in fact we're not going to cut back our energy use and we're going to use these other things, and nuclear power will help us to control the greenhouse gases and get through it, then it looks like an insane gamble, but a reasonable gamble, and one to be done as well as possible. So these are I'm not even sure of my position on these things. My position personally has been, not nuclear. It's wildly the risk is, at a planetary scale, the existential risk is just massive, especially if we keep increasing the number of plants, and the same with geoengineering. But now the consequences of climate change and the possibilities we'll actually address it seem so far-fetched, it actually may be coming back to a point of debate. This is a point of fierce debate. Please don't see me tilting one way or another. Just be aware of that's where it's happening. There's other sort of things like injecting CO2 into the ground, other sorts of things to kind of carbon capture. Again, these are short-term solutions. The other danger with these sorts of solutions, or even putting them in the air, is they could actually become, in a sense, self-fulfilling prophecies, because people will think, oh, we can do this, so we don't have to worry about doing the other things, where really those who are advocating for these are just doing it to buy us time while we draw down our production of CO2 producing gases. Okay. This is just about comparing the stakes of climate change to the stakes of the pandemic, and the willingness and the availability to afford to address an issue. Again, the pandemic, of course, is terrifically serious, but as bad as it is, the future of what climate change could do is not only comparable, but probably even more significant in the long run. It's a little abstract because we don't know yet how this pandemic is going to play out with the different variants. All right. Glacier melt, significant. Again, I've talked about why that's significant. I've talked about the ice shelves melting, and again, part of Antarctica has actually gotten colder. There's been an increase, but in other parts, the loss has been more significant, and where it is in terms of containing ice up on land is more significant. That relates to sea level rise. This, of course, has been a common headline for years now. Let me just reference you to this article. This is an interesting case to keep track of. Climate change then relates to endangered species, habitat loss. We have all sorts of protected areas and all sorts of different species that interact on particular timetables in particular regions. As the climate shifts, all that timing shifts, and what the protected range needs to be shifts, and so you have a massive disruption, which with now the growing human population and other spaces becomes a significant problem. This is something I've talked about. This again goes to the disproportionate impact on the most vulnerable. And this is just, and this is from, what's today? Oh, this is from today, this morning's. It's just the headlines about all this environmental stuff are really daily headlines. And I keep looking, there are some good ones actually. There's some good news out there. But it's also important to keep track of the realities. Okay, so that's it. This is the longest of the segments I'm going to do on the various issues. This is related to climate change. As long as this took as many things as I named, this is still just, not to be crass, but the tip of the iceberg in terms of the complexity of the issues involved and the seriousness of the challenge, and the role of faith communities in both calling us to love all creatures and all creation. So the reason we want to address climate change is not just for humans, but for all creatures and all creation, and out of a vision of love, which leads us to be also empowered as we're in relation to these other creatures and in creation, and as we look to give voice to values that are other than those that are economic. Economic values are real and important values. But what's also important is that the values of all the world's religious traditions, which, as I've argued in several of my books, are amazingly congruent. There is massive overlapping consensus among the world's religious traditions about basically how we should care for other creatures, how we should care for creation, how we should care for all others. Those voices need to be given not just a space for expressions of hope and ideals, but as, again, Pope Francis has proposed with this Laudato Si, those voices need to be in the negotiating rooms, at the tables, where and part of the values that inform the ways we're going to govern ourselves globally moving forward in an age where we are really like gods on earth. As I also said in some of my books, we really have become. It's like the science fiction tales where, for some reason, you have a starship that can blow up planets, and somehow the children have taken control. And the hope is they're going to manage to take care of things without blowing anything up. And in a way, we're now the children actually in control of the future of this iteration of life on Earth. And so let's hope that we can rise to the task with the wisdom that we have been given by our elders.